All right, so brief review of exponential and logarithmic functions. By the way, we are in 3.1 now. I kind of do 3.2 and 3.1 in the books, a little bit mixed, but this is the material from 3.1. So we're interested in functions of the form f of x equals a to the x. We do require a to be positive. I don't want to have a negative raised to a power. And I do require a not to be 1. Think about what would happen if the base was 1. You just get a flat line, which is not what we're interested in. And so I want to give you two graphs. There's two possibilities for the graph of this. It all depends on your choice of a. The classic graph that you're familiar with looks like this. And this is the graph when a is actually bigger than 1. But it's possible that a is less than 1, that it's between 0 and 1. And in that case, the graph actually comes down and looks like that. It's a reflection of this graph just across that y-axis. And so this is the situation when a is between 0 and 1. And so both of these are graphs of a to the x. So try to get those two graphs in your mind. We are going through the point 0, 1 in both cases. And both of these, you can see that the domain is everything. You can plug in anything you like. And in both cases, the range is 0 to infinity. A couple of things that, these are very basic, but they really tend to trip students up. So just the rules of exponents. So base a to the x times base a to the y, you add the exponents. Let me plug in my battery here real quick. We are running low. Okay, so you don't multiply a times a and get a squared. You simply add the exponents. Same base, when you're multiplying, add the exponents. A to the x all to the r, then you multiply and you get a to the r times x. If you have different bases raised to the same exponent, then you get a to the x and b to the x. And then finally, if you have a to the x over a to the y, then you can write this as a to the x minus y. We've talked about this before. You guys know this. Or if you want, you can write this as 1 over a to the y minus x, depending on what you need. So those are just the basic rules of exponents. And these are the basic graphs of the exponential functions. These graphs do actually contain some key limits that I want you to realize. And so I want to write those down. I'm going to write them down here. I would encourage you to think about them without necessarily having to graph the picture, but these come from the picture, and I'll scroll up and let you see that in just a minute. So first off, let's assume a is bigger than 0. And let's consider the limit as x goes to infinity of a to the x. When the base is bigger than 0, as x gets big, this function is getting big. This is an exponential function. So, of course, this is just infinity. And when x goes to minus infinity, let's look back at our graph. A is bigger than 1. So as x goes to minus infinity, your curve is getting closer and closer to 0. So we want to know those limits, and they're basically just backwards when a is less than 1 but bigger than 0. It just flips it. So now as x goes to infinity, a to the x is going to 0. It's decaying down, and then vice versa. It goes to infinity as x goes to minus infinity. So the limit as x goes to minus infinity of a to the x is actually infinity. Okay, so let's do an example of this just to make sure this is clear. You'll be expected to do some of this in the homework. So the first one here is, let's compute the limit as x goes to infinity of 3 to the minus x plus 2. And I actually want to work this out two different ways with you. So here's solution 1. We can write this as limit as x goes to infinity of, and I'm going to write 3 to the minus x, whoops, let's erase this. I'm going to write 3 to the minus x as 3 to the minus 1 all to the x plus 2. And please realize I can multiply these and I'm right back where I started. I've changed nothing. And now I can say, well, this is equal to the limit as x goes to infinity of 1 over 3 to the x plus 2. And now we say, okay, wait a minute. 1/3 is less than 1. This is small. And so as x gets big, this part's going to 0. And so I just get out 0 plus 2, which is 2. So there's one solution. Now let's do it a different way. Let's do solution 2. And I'm not saying either one of these is better, but you can say, okay, look, there's a negative here. That flips the whole thing down, and so I get the limit as x goes to infinity of 1 over 3 to the x plus 2. Now I realize, hey, as x gets big, 3 to the x gets big. This is going to infinity, so the whole thing is going to 0. And so we can just say, well, then this is the same thing as 0 plus 2, which is 2. And I can say, well, this goes to 0. And the reason is 3 to the x goes to infinity. So in some ways, this, I think, flipping that negative down like this is perhaps the easiest way to do it. But you need to be comfortable with either one of these. All right, well, let's break this video here. Not much left. You guys are doing great. But we'll have a couple of videos left, and then we'll be done with these sections.